Anthony, I would love to have statistics on how many people made our jingle their ringtone yet. You think there's data on that out there? We probably should
I
have a
don't know.
REST API that publicly exposes all that data. I'm pretty sure
Right.
Davide is one of those folks that already did that. Right? Anyways, let's not talk about the jingle, besides the fact that the jingle is the best ever out there, ever created jingle. Anthony,
Yes, Ben.
are we going to talk some tech today?
We are going to talk some tech today. We've spent so much time so far talking about 25 and AI and all the super awesomeness around that. We're going to shift gears. Maybe some might consider something a little bit more mundane, but I've always gotten excited over this topic because I love to make things go fast. We're going to talk about backup compression, Ben.
Nobody cares about backups, Anthony.
Nobody cares about backups. In fact, when I talk to customers, especially when I was a consultant, I would say that. I mean, listen, nobody actually cares about backup. What they care about is restores. And that's what we're going to
Fair.
focus on today, right? Is how this new backup compression algorithm not only does it impact backup rates, but has a dramatic impact on restore rates.
All right.
Ready to get
Let,
started?
let's dive in.
Cool. All right. So here we can see I am on CTP 2.0 and I have a moderately sized database because we're going to run a bunch of backups. And whilst I do like to make things go fast, we're going to run a backup of a database that's not exactly that big in size, but just enough size to show the impact of this new backup compression algorithm. So let's go through a couple of things first. When I work with systems, I want to establish kind of a high watermark or a benchmark of
I see what you did there.
the performance of the system. And so what we're going to do first is we're going to take a database backup. We're going to write it out to null. And I'm going to specify with no compression for that backup. So let's go ahead and run this code and see what we get. So we are reading at about 3,902 megabytes per second from disk. This is basically as fast as I can do what's called a single threaded read from the source system. Basically, how fast I can rip those bits and bytes off the wire. And then I'm going to throw them out to null because I don't want to have the impact of the write in the performance metrics that I want to calculate. And so this is quite literally as fast as I can go. And really that becomes kind of the target for how fast I want to back things up. What's up, Ben?
No. That makes perfect sense.
Totally.
Even I get that, and I don't care about backups. By the way, did you know that backups and snapshots are the same thing, basically?
I have a whole blog series exactly about that, Ben.
Ooh.
We should add that to the show
read that.
notes.
We should.
Now, that was with no compression. So how fast I can read it. So let's look at the impact of adding compression to that. So I'm going to have a backup database here on line 14. I'm going to say with compression. I'm going to specify the algorithm as the, I guess say, I don't want to say legacy because that sounds kind of like not nice, but let's just say the previously implemented backup algorithm, MS Express, which I think has been around since what, 2005, 2008, Ben?
I think 2005, actually.
20 years ago, Ben.
And I think legacy is fine. Just don't call it old.
Traditional. So let's go ahead and run this here and look at the influence of the compression algorithm on the read rate. So I'm going to read the bits and bytes off. I'm going to compress them and I'm going to throw them out. And it cuts it almost in a quarter, Ben. We're just shy of a gigabyte a second or 995 megabytes per second. So that's a pretty significant influence on the read throughput. Is that right, Ben?
Absolutely. I mean, that basically means it takes 4 times as long. I did the math in my head.
Yes, you did not need AI to do that.
Fair.
And it would have given you an approximately wrong answer anyway. So let's look at the impact of the new backup compression algorithm called Z standard, or ZSTD. So backup database, TPCC. Again, I'm going to write to null. I'm going to specify here on line 24, algorithm equals ZSTD or Z standard. It's going to run that backup together and look at the influence of that. Now we're at about 2,000 megabytes a second, which is a pretty good rate. We're getting closer back to I don't say closer back to the read rate, but we're definitely added some horsepower to the party, right? We're double that of MS Express, right? Cool. So now that we know,
also keeping in mind, all you did is you changed the algorithm, so there was no code refactoring or anything involved. Because that's always, sometimes you have changes where like, yeah, I can change that, but that's going to have a gazillion of impacts and changes and refactors and whatnot. It is literally one word that you changed or the name of the algorithm.
Yeah, 100%. And I think when we look at especially backups in the cloud or performance sensitive systems where you don't have a lot of CPU to spare, or you're a
Yep.
24/7 shop and you have transactions happening all day long. Well, if I have to dedicate a bunch of CPU horsepower to backup compression, which is, it's a very important thing, that's going to potentially impact the user workload, right? Which could have some dramatic impacts to a business. And also, we're not going to cover it so in so much detail today, but the influence of the backup algorithms and size, we'll cover it a little bit at the end. But I have a whole blog post that goes through kind of the nuances of what the output of the backup file size is. Some customers that I've worked with don't use compression at all, and they just deal with the full size of the data as it lands on that backup target because it's faster in some scenarios. Cool. So let's look at actually writing backups to a thing. Because backups and all, not exactly the best recovery strategy,
Yep.
but a good way to establish a baseline, right? Benchmark. So
That
with
should be a sticker.
totally. So in SQL Server 2022, Ben, did you know that you could actually back up and restore from object over S3? Did you know
Um, I may have heard about that in a pre-con that both of us presented together,
that?
but
True story.
I
So
got
let's go ahead
fond
and
memories of that pre-con. You want to get me want me to get into the details of what I remember about it,
let's
or
not cover the details, Ben.
okay?
Let's not cover the details. So
It
let's
was
go
a
ahead and run
great
it back.
pre-con, folks.
Let's go ahead and run it back up in object. And so here I'm going to write into 4 backup files with no compression again to kind of establish the high watermark from a write standpoint. So I'm
Uh-huh.
getting just shy of about 400 or just 450 megabytes per second or 445 megabytes. So we want to be able to influence that. So that's how fast I can write into this object device. And so we look at, and again, that's a single threaded write. Or excuse me, it's 4 write threads off a single threaded read. So that's why you're kind of seeing a slower rate there. Now, MS Express, we're going to run that. We're going to light up the legacy compression algorithm here to see how fast it writes into object. And we're going to see it's going to hit at about 646 megabytes a second. So we're writing a little bit faster. The rate that it's traveling over the network isn't really changing here. What's happening is we're compressing and writing less stuff, which is increasing the perceived write rate. Now let's apply the Z standard low to the backup here. Going to run that and see what the influence of that is on the runtime of the backup. Now we're getting back up to about a gigabyte a second again. Let's going to run that again to see if we get a better rate. Just at about
Pretty
1020
stable.
megabytes per second. Yeah, so good stuff there. Now with Z standard, we have the ability to kind of tune the compressibility of the backup, right? So we did low there because that's going to be the highest throughput rate, but it's going to yield a larger backup file. We have the ability to apply medium. It's going to run that there, and it's going to apply more compression to the backup stream, which is going to increase CPU utilization, will also impact the throughput rate. So let's see the impact of that. Now we're back down to about 424. That's usually on par with MS Express in terms of throughput rate and compressibility. We also have another knob to turn, which is Z standard high. I really haven't seen a lot of great influence on backup size here. It increases the run rate a bunch and only ekes out about a single digit percentage of compressibility compared to medium. So there we see, it basically cuts the
Yeah.
runtime in half, or the throughput rate in half, and increases the runtime by 2. So let's do a quick analysis
I was
on.
going to say, how much did we actually save? Because that's the other thing, obviously. Storage is free until it isn't. So,
Oh yeah. So let's go ahead and look at the backup history. So if I look at the things that we just did, obviously in the backup history, we won't see any of the null stuff here. I eliminated that. I'm just focusing on the ones that were written out. So if we look at compression to MS Express over S3, took about 6 seconds. The backup file is about 2.2 gigabytes, and that gets us about a 42% compression ratio. Z standard low cuts the runtime in half, which we observed. Although the backup file, the set that's in our object store, is a little bit bigger, right? It's about 2.8 gigabytes, and about a 30% compression ratio. I ran 2 of those, so here we can see that second backup there,
yeah.
and then we have our Z standard medium. We definitely get back towards the magnitude or the compressibility of MS Express. at about 44%, but the runtime is a little bit higher. And then Z standard high, we eke out about a single digit percentage, maybe even just half a single percentage there. And the backup file is only about 20 megabytes smaller, but we doubled the runtime. So really, I don't see a lot of applicability of that backup algorithm. But Ben, since nobody cares about backup, let's talk about restore. If I want to restore from no compression, but this will be
Hang
kind of
on.
the yes,
Don't we
go
need
ahead.
to build the same baseline and restore from null first?
I don't even know how to respond to that, Ben. What- those bits and bytes are gone. They are in the null bit bucket, right? Forever. It's like the black hole of data.
That's the saddest thing I've heard all day.
True story. So let's establish how fast we can read from the system. We're going to restore with no compression. So there's no CPU impact here in terms of decompression on the restore. So it's going to run this code. We're going to see a pretty good restore rate of about 1,852 megabytes per second. Going to restore from MS Express to see how fast we can pull from that. That's going to decompress into CPU and then write into our block device on the target. 744, so more than half in terms of speed on the restore. So big impact there on CPU
Yep.
burn. Now, if I use our Z standard low as the restore system, this is the dramatic impact. 1,800 megabytes per second. This is
That's like
almost as
uncompressed.
fast as uncompressed, right? That's the value here. We have a little bit of bigger backup file. We definitely are using some CPU when we create the backup with compression, but this is dramatic, right? In terms of it's almost the same exact rates as no compression. And so imagine that from a restore standpoint when you're building recovery, but also at the benefit of saving some storage capacity in your backup set. So not exactly the whiz bang features of AI and JSON and all the cool stuff they're getting out of 2025, but definitely a huge impact on a DBA's day to day life, and also the recovery objectives for an organization, being able to have compression and a restore rate that
Yeah.
matches with no compression. You want to bring it home, Ben?
I think the thing how we could summarize this is basically you have to kind of make a, and feel free to agree or disagree with me on this one.
Hmm.
With the new ZSTD, you basically have a choice. Either you're going for slightly bigger files in exchange for much faster backup and also much faster restore, or you go from the low to the medium, which basically gets us to the same size. I mean, your mileage may vary, and also different data compresses differently. But you could go to
Yes.
medium, get about the same file size and the same restore time, and the same backup time, but still with a faster restore.
Okay.
However, low seems to be the biggest impact or the actual game changer here. If you're willing
Totally.
to take those, in your example, about I'm going to say 25% in extra storage. That
Yeah.
fair?
Yeah, and I think, the important thing to discuss is obviously the compressibility and performance is very much so database specific, very
Yeah.
much so infrastructure specific. So this certainly needs to be tested in an environment. But I think the idea of having some additional knobs to turn from a performance standpoint are what's important. Because historically, to protect a system that was CPU sensitive, we had to do something complex like resource governor, and it really didn't influence the backup size. But I could kind of control the utilization of a backup leveraging resource governor. This gives me a little bit more granular control without having the complexity of a resource governor implementation.
Okay. Now show me how you can do a single table restore from this.
Ben, let's be serious.
I've been waiting for that for so long.
So long.
So long. The only thing that can make me happy now is a jingle. So I would say it's time to play the music.
Time to play music.